Hi everyone, and welcome back. So what we're going to be working on this week is finishing up our trigonometry unit. I know, very exciting. Okay, so I'm going to break up this lesson into two different lessons for us. So what we're going to be practicing is what you've already been doing, which are solving trigonometric equations, whether they're quadratic or linear, as well as proving trigonometric identities using the sum, difference, angles, as well as the Pythagorean identities. So let's take a look at the first example. I have cosine squared x plus sine x is equal to 1. And the directions say we are going to solve for all angles within the given interval. So we're in radian mode. But if you want to think about this in degrees, you're going from 0 to 360, but not including 360. And we're going to round it to the nearest hundredth of a radian. Okay. All right, so first things first. For this very first question, I know I was getting a lot of questions about the delta math regarding these trig identities. Notice how I have a quadratic in terms of cosine, and then I have a linear function of sine. So I don't ever like to solve quadratics in two different variables. We want these both to turn into either all sines or all cosines. Now, I can't change this sine into a cosine. It's not going to happen. So that's out of the picture. I can't change that. But what I can change is cosine into sine. Because from our trig identities of sine squared x plus cos squared x equaling 1, we know cosine squared of x is the same thing as 1 minus sine squared x. So I'm going to replace this cosine squared of x as 1 minus sine squared x, plus we have the sine x equals 1. Now everything is in terms of sine, and I can solve this no problem. So I have negative sine squared x plus sine x, subtract over the 1, which equals 0. I'm going to divide actually everything out by negative 1. That way I'm dealing with positive sine squared. So I have sine squared x minus sine x equals 0. All right, hopefully you have this written down. I'm just going to clean this up and use the information up top just so we have enough space here. Okay, and now I'm going to take out the GCF of the sine x, and I'll be left with sine x minus 1 equals 0. T-chart, I'll have sine x equals 0 and sine x equals 1. I'm going to look at my unit circle. We have the point 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. So where does sine equal 0? So remember, sine is always the y value, so I'm going to highlight all these y values. So where does sine equal 0? Okay, very good. So that's at 0 radians. So at 0 radians, right? We're dealing with radians, not degrees, as well as pi radians. Okay, so that's where sine is 0. Now, where is sine equal to 1? Well, that's at pi over 2. So those are your angle measures, guys. Okay. And typically we want to write these from least to greatest, my apologies. So it's really 0, pi over 2, and then pi. So a set of those numbers. And those are our values for x. Fantastic. Why don't you see if you can give question 2 a try, remembering to use those trig identities. That way you're dealing with either all of cosine, all of sine, all of cotangent, whatever the trig function is. You want to just be using one of them. So see if you can figure out what you should be replacing cosine of 2x as. Okay, I think I heard someone say it. We should replace cosine of 2x as 1 minus 2 sine squared x. This is one of the double angle formulas, one of the double angle identities. You want to be referring back to those guys. Again, if you're going into calculus next year, you actually need to have all these memorized. They will not be given to you. Luckily, you have the sheet right in front of you, so you need to be referring back to these. Okay, so now I'm just going to simplify. This is really negative 2 sine squared x plus sine x plus 1. Again, I don't like to deal with a negative in front of my x squared term, So I'm going to divide everything out by -1. So really, I'm looking at 2 sine squared x minus sine x minus 1 equals 0. We're going to do tricky trinomial here, or factor by grouping, whatever you prefer, and we're going to solve for x. So again, I'm going to clean up what I have here. I'm going to rewrite this up top, and you guys can follow along with me there. Okay, so after I go through all of the steps, again, you probably solved this using tricky trinomial, you still should end up getting sine of x to equal -1/2, and then sine of x to equal 1. If you need to pause the video here and just take a look at my work before I erase that, that way we continue on now to find those angle measures. Okay, so now that we have our two values for sine, we want to come up with the angle measures. So I note that sine is -1/2, meaning if I look at my quadrants, all students take calculus, sine is negative, so I'm going to be looking in the third and fourth quadrant. Now, it's important you know the reference angle. Once you know the reference angle, you can figure out what these two angles are in each of these quadrants. Sine of what gets you to 1/2? Very good, pi/6. So if I know my reference angle is pi/6, well, in the third quadrant, that angle measure is 7 pi/6. And then in the fourth quadrant, that's 11 pi/6. Now, this next one is actually a little bit easier because that falls on the quadrantal angles. If I want to know where sine is equal to 1, well, remember, we have either these two values where sine will be 1. Now, remember, sine equaling 1, that's the y value, and that only takes place at pi/2. So we would have x equals pi/2. So our final answer would be x equals, we have pi/2, 7 pi/6, and then 11 pi/6. So those are my three angles. Okay? Questions? No? Nothing? All right, I guess we'll just keep going. Okay, so for question 3 here, now notice I have cosecant and cotangent. That immediately makes me think of, again, those Pythagorean identities when I see something being squared. Because remember, the original is sine squared x plus cosine squared of x equals 1. You can always derive these. So if I want to get these in terms of cosecant, well, if I divide everything by sine, sine squared x, I'll have 1 plus cotangent squared of x equals cosecant squared of x. So I just derived one of the Pythagorean identities. I want it to equal cosecant, and it already is. So we're going to substitute this in for 2 times 1 plus cotangent squared x minus cotangent equals 3. And now I'm just going to distribute. So we have 2 plus 2 cotangent squared of x minus cotangent of x minus 3 equals 0 by bringing that over. When I simplify, I have 2 cotangent squared of x minus cotangent of x minus 1 equals 0. And again, you guys can do your tricky trinomial here. I'm going to do my factor by grouping. So why don't you solve this, and let's see if we get the same thing. All right, so pause the video here and see if you ended up getting the same thing as me. So you should end up getting cotangent of x equals -1/2 and cotangent of x equals 1. Now, when we're dealing with trigonometric functions and finding those corresponding angles, we want to have them in terms of sine, cosine, and tangent. So if you remember, cotangent of x is equal to 1 over tangent of x. Or what I can do is just flip the fraction. So I'm going to rewrite this as tangent of x equals -2, and tangent of x equals, this is really 1 over 1, and if I were to flip that fraction, it's still 1 over 1, which is just 1. So these are the two pieces we're going to look at. All right, so pause the video here, make sure you have that written down because I'm going to erase what's on the screen. Okay, so we said tangent of x is equal to -2, and tangent of x equals 1. So when I type this into my calculator, we're going to do tan inverse, because we're finding an angle, tan inverse of -2, and I'm doing tan inverse of 1. Now this one I actually know off the top of my head. Tangent has a value of 1 when the reference angle is equal to pi over 4. That comes from that table chart. So if I look, all students take calculus, tangent's positive here and here. So my reference angles are pi over 4 and 5 pi over 4. So that's just for tangent of x equaling 1. Now if we look at tan inverse of -2, well, I end up figuring out that the reference angle, and again, this is all in radians, the reference angle is 1.111, so 1.11 radians. Now, how did I get that? Well, if I type into my calculator tan inverse of -2, you'll end up getting -63.4349 degrees, right? Blah, blah, blah. Okay, well, that's telling me that you're in this quadrant. So if you were to think about that, this went down by -63.43 degrees, so that means its reference angle is just 63.4349 degrees. But I want this in radians. To convert to radians, we multiply by pi over 180. So when I multiply that by pi over 180, that's how I get 1.11. I just rounded. Okay, so that's where this reference angle of 1.11 radians comes from. Now that I know the reference angle is 1.11 radians, and I know when tangent is negative, I'm in the second and fourth quadrant. Well, remember, this is the marker point for 3.14, and this is 6.28, because this is really pi, and this is 2 pi. So if I want my reference angle here, I'm going to take my 3.14 and subtract it with 1.11, and I end up getting 2.03 radians. So that's one of them. Now the other one comes from here, where my reference angle again is that 1.11 radians, and I'm subtracting it from 2 pi. So I have 6.28 minus 1.11. I end up getting 5.17 radians. So that's my final answer, guys. We have pi over 4, 5 pi over 4, 2.03 radians, and 5.17 radians. I know these are a little bit trickier, so if you need to join a Zoom to get some clarification, definitely ask. All right, we're on a roll. Let's take a look at question number 4. Okay, so the first thing I noticed for question 4 is, again, I have a sine here and then a cosine here. Can't change cosine, but I noticed that this is a double angle. So if I have 2 sine of 2x equaling 4 cosine of x, I know that this has an equivalent form. I can rewrite sine of 2x as 2 times 2 sine x cosine x. Remember, that's one of the double angle formulas as I transition from here to here. Double angle formula. You guys need to be using that sheet. Okay, I'm just going to distribute and then also subtract over that 4 cosine x. So I really have 4 sine x cos x minus 4 cosine x equals 0. I'm going to take out the 4 cosine of x as the GCF, and I'm left with sine of x minus 1 inside the parentheses. We're going to do our t-chart. I'll end up getting cosine of x equals 0 and sine of x equals 1. Now I'm going to check my quadrantal angles. Remember, I have a point here at 1, 0, negative 1, 0, 0, 1, and 0, negative 1. So I want to know where cosine is 0. Cosine is the x values. So I want to be looking at all the x values. So where does cosine equal 0? Well, cosine equals 0 at pi over 2 radians and 3 pi over 2 radians. Now, the next piece I want to look at is, well, where does sine equal 1? And now that's all of the y values. Where does sine equal 1? Well, that's at pi over 2 radians. So there's my final solution, because this is also at pi over 2 radians. Okay? Technically, you have a double root there at pi over 2. Okay, let's keep going through. Let's take a look at questions 5 and 6. You guys are doing great. So what's the first thing you notice for question 5? What's the problem? Well, the problem is I have sine and cosecant, and it either all needs to be in terms of cosecant or it all needs to be in terms of sine. Now, there's no double angle formula here, but I want you to think, how can I rewrite cosecant? What could that be represented or written as in terms of another trigonometric function? Very good. I could rewrite cosecant of x as 1 over sine. Now that I have this written out, we're going to subtract over the 1 over sine x. So I have 2 sine x plus 1 minus 1 over sine of x equals 0. Right? We always set these things equal to 0. But you're probably asking, but wait a second, it's not even quadratic. Why am I setting it equal to 0? Because watch what I can do. If I multiply every single term, by sine x, everything gets multiplied by sine x. Watch what happens. I have 2 sine squared of x plus sine x minus 1 equals 0. Now it's quadratic, and you guys know how to solve quadratic functions. All right, so why don't you pause the video here? Why don't you write out your tricky trinomial? I'll solve it with grouping, and let's make sure we get the same answer. All right, so hopefully you got the same thing as me. So I have sine of x is equal to a half, which is here, and then sine of x equals to -1. So make sure you have the same amount of work as me, or same work as me. That way I can erase this, and we can now actually figure out the angle measures. So I would pause the video here, make sure you have this copied down, and let's actually now check those angles. Okay, so now let's check the quadrants. So we know that sine is equal to positive 1/2. So I know I'm in the first 2 quadrants here. And now for sine being -1, remember those are along the quadrantal angles. So I'm looking at, I have the point 0, 1, 1, 0, 1 negative, or -1 comma 0, and then 0, -1. All right, so let's deal with the sine of x equaling a half first. You should know that the reference angle is equal to pi over 6, right? Sine of 30 is equal to a half, so sine of pi over 6 is equal to 1/2. I am looking in the first and second quadrant. So I already know one of them is pi over 6. My other angle measure is 5 pi over 6 because I'm in the second quadrant. So that takes care of sine of x equaling a half. Now, where does sine of x equal -1? Well, that's right here at 3 pi over 2. So there are your 3 angles at pi over 6, 5 pi over 6, and 3 pi over 2. Okay, let's take a look at question 6. So for question 6, I like how everything is in terms of cosine. That's awesome. But now, I can't actually do anything, though, with what I'm given. I can't just factor out a cosine of x. This has a 2 out front. You can't separate them. So I want to use my double angle identities. If this is already in terms of cosine, I want to keep this in terms of cosine. So I'm going to use my 6 times 2 cosine squared of x minus 1 plus 3 cosine of x minus 1 equals 0. I just subtracted over the 1 on both sides. Okay? So if I look, all I did was just substitute in this cosine of 2x. Cosine of 2x is the same thing as 2 cosine squared of x minus 1. We're going to distribute. So I have 12 cosine squared of x minus 6 plus 3 cosine x minus 1 equals 0. We're going to combine our like terms. So I have 12 cosine squared of x plus 3 cosine x minus 7 equals 0. Now you'll notice this does not factor nicely, so I'm going to use the quadratic formula. So why don't you pause the video here and do the quadratic formula here with me. Okay, so these should be the two cosine values that you end up getting. We have cosine of x is equal to 0.648924, blah, blah, blah. And then we have, oh, I wrote 9. This should be an 8. Sorry. And then we have cosine of x is equal to negative 0.898924, blah, blah, blah. It continues. All right, so I'm going to erase what I have here, cleaning this up, and we're going to continue to keep solving this. Okay, so first things first, I notice for the first example here, cosine is positive. So you know that you are in the first and fourth quadrant. And I notice for the second one, cosine here is negative. So we are going to be in the second and third quadrant. All right, so that's at least taken care of. We know which quadrants we're in. Now, if I take cosine inverse of this 0.648924, blah, 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 I end up getting in radians that this has a reference angle of 0.8646, blah, 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 radians. So that's the reference angle. So if I know the reference angle here is 0.8646, blah, 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 that's one of my angles. I already know one of my angle measures is 0.8, and we round this to what? The nearest hundredth? So this will be 0.86. That's one of the angle measures. Now, if I look, I'm also in the fourth quadrant, remembering this has a measure, if I wrap all the way around, of 2 pi, which is the same thing as 6.28, roughly. We approximate that. So I have 6.28 minus my reference angle here of the 0.86. And when I subtract that out, minus the 0.86, I end up getting 5.42 radians. So these are my first two angle measures that fall for cosine of x equaling 0.648, blah, blah, blah. So those are my two radian measures. We want this in radians. Now if I take a look at cosine of x equaling negative 0.89, again, I'm going to go into my calculator, take cosine inverse of that value, so negative 0.898924, and I end up getting my angle to be 2.6881, blah, blah, blah. So I know that's telling me one of my angles right here. Why do I know that? Because 3.14 is here and 1.57 is here. So that means 2.68 blah, blah, blah is within this quadrant. So I already got one of the angles. One of my angles for x is 2.6, and we round that to 2.69. Rounding that to the hundredths. Now, I want the reference angle. So if I know this angle from here to here is 2.68, if I subtract that from 3.14, right? So if I subtract that, I have that 3.14, really 159, right? Because we're looking at pi. And I subtract that from my 2.6881, blah, blah, blah. I end up getting 0.45349. So that's my reference angle. If that's my reference angle, well, that means I know from here to here is that 0.45349. So I'm going to add that to my 3.14159 value for pi. So I'm going to add that now to pi to get this whole angle, because we're adding on that reference angle now. Okay. Again, guys, if any of this isn't making any sense, you need to join a Zoom session. So please, please do that. So we end up getting here, remember, you don't want to round too early. We end up getting, when I add these, so that 3.14 plus the 0.45349, and pi is really 3.14159, blah, blah, blah. I end up getting 3.59508. We round to the nearest hundredth, so I get 3.60. So those are all of my angles. I have 3.60, and this is all radians. So I have 0.86, 5.42, 2.69, and 3.60. Again, guys, this is all practice for you. So if you already understand this, you get the hang of it, you can fast forward, you can rewind, you can skip around, get to the point of whatever you need to make more sense to you. So that way you feel confident in working on your homework. All right, so if we flip over to the next page, I want to take a look at question 7. Now, there was a typo on my end, so I apologize. This should have said sine squared of beta. All right, so just make that change. That should have said 1 minus sine squared of beta. Okay, so we're doing a proof. So remember, we only work with each side of the equal sign, like one at a time. So I'm going to do the left-hand side and then right-hand side. Do not cross multiply. Do not subtract things over to one side or the other. You work with each side separate. So what I'm going to do first is I'm just going to rewrite the problem here. I have cotangent squared of beta all over 1 plus cotangent squared of beta equals 1 minus sine squared of beta. Okay? I recognize immediately that I have Pythagorean identities. I can rewrite both cotangent squared of beta and 1 minus cotangent squared of beta. You need to know your identities. Cotangent squared of beta is the exact same thing as cosecant squared of beta minus 1. And 1 plus cotangent squared of beta is the same thing as cosecant squared of beta. Right? And this is all still equal to 1 minus sine squared of beta. Next thing I can do, using the heart method or pretzel method, whoever taught it to you, however you remember it, I'm going to separate these into two fractions. So now I have cosecant squared of beta over cosecant squared of beta minus 1 over cosecant squared of beta. Cosecant over cosecant is just 1. 1 over cosecant squared can be rewritten as sine squared of beta because of the reciprocal trig functions. And if you look at that, we solved this by proving our trig identity that this is true. So this works out. Okay, maybe if you want to pause the video here and make sure you understand all these steps, and why don't you give question 8 a try? Be on the lookout for those identities, whether it's a sum and difference identity, double angle identity, Pythagorean identity. You need to be on the lookout for those. You're always going to be substituting in for different trigonometric functions. All right, so pause the video here and see if you can give number 8 a try, and let's see if we get the same thing. Again, they have to be proven. So once you can check off that the left-hand side equals the right-hand side, you're done. Okay, so this is what your proof should look like. Again, pay attention to all the substitutions. I used a Pythagorean identity right away to make my substitution. I substituted in here that tangent is the same thing as sine over cosine. I substituted that cosecant is the same thing as 1 over sine. And I substituted that secant is the same thing as 1 over cosine. So pay attention, lots of substitutions going on. And as you can see in the end, I proved the left-hand side is equal to the right-hand side. You'll actually probably see that abbreviation as well. LHS for left-hand side is equal to RHS, right-hand side. Okay, guys, let's keep going. You guys are doing awesome. So why don't we take a look at the bottom two problems? And again, like I said, this is all practice for you to make sure we get a little bit more comfortable with these identities. I'm going to do question 10 first. We are going to do both 9 and 10. I want to do question 10 first, and then we'll do question 9. So for question 10, I apologize for the lack of space. I actually am going to take up most of this space here with the left-hand side because, as you can see, this is a sum and difference proof. Okay, so I'm going to leave the right-hand side alone for right now, and I want to take a look on the left-hand side. So if you remember from your sum and difference identities, we can substitute these two formulas. So what I'm going to do first is I'm just going to write out, we know that sine of A plus B is the same thing as writing sine of A cosine of B plus cosine of A sine of B. So that's the exact same thing. Actually, I'm going to need even more space, so hang on. Okay, so I just substituted in sine of A plus B is the same thing as sine A cos B plus cos A sine B. Now I'm going to take a look at cosine of A plus B. So again, that's another sum identity formula. So we can replace cosine of A plus B as cosine A cosine B minus sine A sine B. Again, everything here that I'm doing right now is all left-hand side. I just did not give you enough space here, so I apologize. And this is all over sine A. Now, before I start to combine like terms, I need to get the denominators to be the exact same, and they're not. So what I'm going to do is I'm going to multiply the left-hand side by sine over sine A, and then the right-hand side by cos A over cos A. So let's write that out. I'll have sine A over, we have sine A cos A, and then I'm multiplying everything by sine A. So I have sine A of sine A cos B plus cos A sine B. And then now for the right-hand side, everything's getting multiplied by cosine of A. So I have cos A times cos A cos B minus sine A sine B all over sine A cos A. So now I'm actually just going to start to combine like terms here. So I'm going to distribute a little bit. We'll end up having on the top sine squared A cos B plus cos A sine B plus, distribute here, cosine squared A cos B minus cos A sine B. And this is all being divided by sine of A cos A. Now, if you notice, terms that can cancel out is this plus cosine A sine B minus cosine A sine B. Those go away. So now I'm left with sine squared A cos B plus cosine squared A, forgot the A here, cosine B, and this is all over sine A cosine A. Again, we can still simplify. I'm going to take out the cosine B, and I'll be left with sine A squared plus cosine squared A all over sine A cos A. Okay, so if we remember, sine squared A plus cosine squared A is equal to 1. So really all I'm left with is cosine of B all over sine A cos A. And now we are finally done. So if we take a look, this is all work for the left-hand side. Everything here for the left-hand side, in the end, ends up equaling the right-hand side. Cos B over sine A cos A is the same thing as what we have here on the right-hand side. So that's all the work that we need for question 10. Now I want to take a look at question 9, and then we're going to wrap it up there. So make sure you have this all written down. I'm going to erase what's on the screen. Alrighty, last one. So again, this is a proof, and we're going to work with the left-hand side and then the right-hand side. So right-hand side I'm actually just going to leave alone. Alright, so that's just equal to tan theta. On the left-hand side, immediately I recognize I can rewrite sine of 2 theta as 2 sine theta cos theta plus that sine theta. That's one of my double angle substitutions. Next thing I notice is I have another double angle on the bottom where I have cosine of 2 theta. Now there are 3 options for cosine of 2 theta. Some of this is really trial and error, guys. Sometimes even I start off with the wrong one, but then you'll recognize where you actually need to go. So I actually recognize that cosine of 2 theta I want to replace with 2 cosine squared theta minus 1. And then I'm just going to rewrite. I have plus cos theta plus 1. Again, that's from the double angle formula for cosine of 2 theta. Remember, there are 3 options. You got to pick the right one. Okay, I'm going to factor on the top. I can take out a sine theta. I'll be left with 2 cos theta plus 1 all over. Here, if I actually look, this is 2 cosine squared theta plus cos theta after I simplify. I'm going to take out a cos theta on the bottom, so let's just rewrite the numerator. So I'm going to take out a cosine of theta, and I'll be left with 2 cos theta plus 1. Now, if you notice, these 2 things are the exact same thing. If I have the same thing over the same thing, that's just 1. So really, all I'm left with is sine over cosine. And what's sine theta over cosine theta the same thing as? Tangent. Very good. So I have the left-hand side equals the right-hand side. Nothing had to be done to the right-hand side. So I have tan theta equals tan theta, and we are finito. All right, guys, I hope you found this video helpful as you continue to work on those delta math problems. You have that quiz coming up this week, so if you have any questions, please feel free to reach out to me, all right? I miss you all, and I really, really do hope to see you soon. Please keep in touch. We'll talk soon.